In the realm of machine learning, surrogate models are employed to approximate the predictions of complex target models, enhancing interpretability and transparency. These simpler models can be decision trees, rule sets, or generalized additive models, GAMs, which provide insights into the overall behavior and global predictions of target models. This paper introduces DeforestVis, a visual analytics tool designed to summarize the behavior of complex ML models using surrogate decision stumps generated with adaptive boosting, AdaBoost. DeforestVis aids users in exploring the complexity versus fidelity trade-off by incrementally generating more stumps, creating attribute-based explanations with weighted stumps to justify decision-making, and analyzing the impact of rule overriding on training instance allocation between one or more stumps. An independent test set allows users to monitor the effectiveness of manual rule changes and form hypotheses based on case-by-case analyses. The applicability and usefulness of DeforestVis are demonstrated through 2 use cases and expert interviews with data analysts and model developers. This paper introduces DeforestVis, a visual analytics tool designed to simplify the behavior analysis of complex machine learning models through surrogate models. DeforestVis leverages the adaptive boosting, AdaBoost, method to create decision stumps, which are one-level decision trees. The tool allows users to trade off complexity of the visual explanation against fidelity of the surrogate, providing summaries of decision boundaries and feature contributions to a test set. Users can also inspect the influence of individual decision stumps and observe both local and global impacts of rule changes. The algorithmic steps of the AdaBoost surrogate model used in DeforestVis include training a target model on a dataset for binary classification, creating a surrogate model using AdaBoost, and fitting individual decision stumps based on Gini impurity metrics. The impact of weights is also discussed, highlighting the importance of weighted probabilities and the influence of each stump in the classification process. DeforestVis builds upon related work on surrogate models for model interpretation and approaches for visualizing rules and decision trees. It is tailored to meet the user goals, analytical tasks, and user types for VA tools using surrogate models for behavior analysis of complex ML models. Section 5 presents the DeforestVis tool in detail, while Section 6 describes a use case for examining alternative decisions and their combinatorial effect when manually adjusting a decision rule. The tool's applicability and usefulness are demonstrated with a real-world dataset for a binary classification problem. Feedback obtained from expert interview sessions and identified limitations are discussed in Section 7, with further reflections on targeted users and potential improvements for the tool presented in Section 8. Finally, the paper concludes in Section 9. DeforestVis is a novel visualization tool designed to provide insights into the behavior of machine learning models by leveraging surrogate decision stumps. This innovative approach aggregates multiple surrogate models with varying complexities, enabling users to explore the trade-off between complexity and fidelity. By doing so, it allows for a more comprehensive understanding of the decision-making process within complex models. In the context of related work, existing visualization techniques for decision trees and rules, as well as surrogate model visualization, are reviewed. The limitations of tools such as Vis Ruler and Strategy Atlas are highlighted, emphasizing the need for a more effective way to visualize and interpret complex models. DeforestVis addresses these challenges by extracting decision stumps from an accurate and simpler AdaBoost model, which approximates the behavior of a complex target model. This tool enables users to override the resulting decision stumps, providing a unique functionality not supported by other visualization tools. The importance of understanding the hierarchical structure of decision trees is also emphasized, a concept disregarded in tools like Rule Matrix and Vis Ruler. Furthermore, various visualization tools that assist with the interpretation or diagnosis of the training process of gradient boosting models are mentioned, such as GBM-Vis and BoostVis. These tools allow for the assessment of feature significance and decision-making tracking, but they do not provide the same level of insight into the behavior of machine learning models as DeforestVis. Overall, DeforestVis presents a novel approach to understanding and interpreting complex machine learning models through the use of surrogate decision stumps and visualization techniques. By aggregating multiple surrogate models, It enables users to explore the trade-off between complexity and fidelity, providing a more comprehensive understanding of the decision-making process within complex models. The authors delve into various visualization tools for machine learning models, such as DeforestVis, GBRT-Vis, VISTB, iForest, EXMatrix, Netu and Pavlovich's tool, Colorful Trees, and RFX. These tools aim to facilitate the interpretation of random forest models, exploring gradient boosting, visualizing decision trees, and providing feature impact comparison. DeforestVis stands out by utilizing AdaBoost to generate decision trees, allowing users to instantly explore rules and compare the confidence of the surrogate model for each rule and feature. DeforestVis is designed with 5 user goals in mind: replacing an unintuitive ML model with an interpretable surrogate model, identifying good solutions for the trade-off between complexity and fidelity in approximation models, analyzing extracted decision rules individually and jointly, understanding the behavior of complex models, and exploring the local and global impact of a manually overridden rule. These goals are influenced by relevant research and guidelines from Munzner and others. The authors also outline 5 analytical tasks that DeforestVis aims to help users complete, following guidelines from Munzner. The tool focuses on binary classification problems and tabular data with a limited number of meaningful features, targeting model developers and domain experts with a basic understanding of information visualization and machine learning concepts. DeforestVis proposes a feature-aligned tree visualization to help understand and analyze rules across multiple one-level decision trees. The tool summarizes decision stumps' predictive power and final predictive outcome collectively in segmented bar charts. To the best of the author's knowledge, no previous work has described the use of visualization analytics in conjunction with the AdaBoost ensemble learning algorithm to generate interpretable decision stumps that aggregate the behavior of complex machine learning models. This research paper introduces DeforestVis, a web-based visualization tool designed to explore the behavior of complex machine learning models using feature-based explanations from surrogate decision stumps. The system aims to provide insights into how the model makes decisions and identify potential biases or limitations, meeting user goals and analysis tasks. The paper outlines 5 key user goals for understanding and interacting with surrogate models, including understanding overall predictive accuracy, identifying influential features, examining model behavior on different groups of training samples, adjusting decision rules based on prior knowledge, and experimenting with what-if scenarios to predict particular test instances in a different class. In terms of analytical tasks, the paper outlines 5 key operations that users should be able to perform using DeforestVis. These include using shallow decision trees to split the complex model and see the impact of information reduction in faithfulness, finding the optimal number of decision trees needed to retain high enough model performance, examining summarized thresholds for each feature that lead to different predictions and drilling down to investigate single decision rules, assisting users in manually adjusting decision rules and providing visual feedback about the impact of their actions, and experimenting with what-if scenarios to predict particular test instances in a different class. The system overview of DeforestVis reveals that the front end is developed in JavaScript using Vue.js, D3.js, and Plotly.js, while the backend is written in Python using Flask and scikit-learn. The tool features 5 main views: A. Surrogate model view, B. Feature importance view, C. Decision stump view, D. Feature threshold view, and E. Test instance view. These views enable users to visualize and interact with the surrogate models to gain a deeper understanding of their behavior and predictive capabilities. DeforestVis is a visualization system designed to facilitate the analysis of machine learning models using surrogate decision stumps. It consists of 5 interconnected views that address specific questions regarding the behavior of the target model. View A presents a lollipop plot illustrating data rounding effects in the fidelity score for different decimal digit precisions, a dot plot showing the complexity increase with added decision stumps, and a selective stump-based explanation. This view provides insights into how the model's complexity and fidelity change as more decision stumps are added. View B displays a segmented bar chart explaining the predictive outcome and power of each segment based on automatically computed thresholds, along with a detailed Stumps-based explanation grid. This view helps in understanding the predictive capabilities of the model and the impact of each segment on the overall prediction. View C presents a bar chart showing the impurity and weighted probability of each decision stump, accompanied by a histogram illustrating the active rules threshold and distribution of training instances. This view provides information about the impurity reduction achieved by each stump and its weighted probability, which aids in understanding the contribution of each stump to the model's overall performance. View D projects the global behavior of instances, with color indicating local behavior according to the selected decision stump. This view allows for the visualization of the model's behavior at both global and local levels, providing insights into how different stumps influence the predictions. Finally, View E displays a fragmented bar chart showing the per-feature contribution and influence level for each test case. This view helps in identifying the most influential features in the model and their impact on the predictions. The system utilizes the explainable boosting machine (EBM) approach, which produces systematically fewer decision rules compared to other ensemble learning methods. The implementation uses EBM with default hyperparameters as the target model, with data split into 80% training and 20% testing sets using a stratified strategy. Hyperparameter space is randomly sampled to visualize each AdaBoost model with an increasingly larger number of decision stumps. The default AdaBoost hyperparameters are used, with the exception of the maximum number of features set to the square root of the number of features. In the realm of machine learning model analysis, DeforestVis is a groundbreaking visualization tool that enables the behavioral analysis of complex models through surrogate decision stumps. This innovative workflow allows users to select an optimal surrogate model by considering a trade-off between fidelity and complexity, explore extracted decisions from the surrogate model, and manipulate individual rules based on visual feedback and prior experiences. The tool's interface features a lollipop plot and dot plot to visualize the balance between fidelity and complexity, enabling users to choose between different surrogate models. The visualization design incorporates a 4-component visual design for decision stumps, which compactly encodes diverse information such as weight, predicted probabilities, and class distribution. Users can also explore decision trees and reason about specific test cases iteratively while examining existing explanations for the training data. The system's scalability can be improved by separating the visualizations into different tabs for selecting the optimal surrogate model. A case study applying DeforestVis on the breast cancer data set demonstrates how it aids in understanding the decision-making process of complex models and identifying influential decision stumps. This novel tool has the potential to revolutionize the field of machine learning model analysis by providing a comprehensive and intuitive visualization of complex model behaviors. The DeforestVis system's behavioral model summarization view is the most comprehensive and largest in size, as it connects with other views. This view features decision stumps, similar to active stumps, but with a color-coded grid replacing the bar chart to display training samples. The grid enables in-depth exploration of which subtree each sample falls into, with misclassified samples appearing closer to the grid's middle. The grid consists of 2 cell groups, one to the left and one to the right, ordered by the predicted probability of each sample belonging to the ground truth (GT) class. Each feature is encoded by a series of decision stumps, with the most important features listed first. The top part of the view shows a segmented bar chart summarizing all decision stumps for each feature, where each segment represents a threshold value. The z-axis encodes all available thresholds separating predictions into different classes, while the y-axis displays the weighted probability for the most probable class above the zero line and the weighted probability for the other class on the negative side. When hovering over a segment, the corresponding decision stump is highlighted, revealing how and with what magnitude the stump votes. The most impure decision stump, based on the Gini impurity measurement, is selected by default and marked in red, as high impurity indicates poor separation between classes. This compact visualization of the complex decision-making process enables users to gain insights into the model's behavior, understanding the importance of each feature and the decision-making process behind the predictions. DeforestVis is a novel visualization tool designed to analyze the behavior of machine learning models using surrogate decision stumps. By simplifying complex models into a set of decision stumps, DeforestVis provides insights into the decision-making process. The visualization consists of three main components: a scatter plot, a bar chart, and a histogram. The scatter plot view displays the distribution of training instances in the feature space, with each point representing an instance. The color of each point indicates the ground truth class, while its size reflects the prediction confidence. This view enables users to identify problematic cases where the model misclassifies instances. The bar chart displays the impurity values of each stump along with their weighted probability scores. The y-axis lists the stumps based on their impurity, with the highest impurity at the top. The currently selected stump is highlighted in red, allowing users to understand the contribution of each stump to the overall model's predictions. The histogram groups training instances into bins based on their feature values, providing a detailed view of the distribution of instances before and after user interaction with the decision stump. The dashed black vertical lines represent the threshold values before and after the user's adjustment, enabling a clear comparison between the original and modified model behaviors. When dealing with large datasets, scalability issues may arise. To address this, the authors suggest aggregating similar samples into larger boxes or replacing the scatter plot with a segmented bar chart. DeforestVis has the potential to facilitate a deeper understanding of machine learning models' behavior, particularly in identifying problematic cases and improving model performance through user-driven adjustments. DeforestVis is a visual analytics system designed to facilitate understanding of machine learning models through the use of surrogate decision stumps. A local analysis is demonstrated in Figure 5, where the most accurate and simple surrogate model is used to predict a test case. The figure displays the certainty of the surrogate model's classification, with misclassified test cases at the bottom. The feature contributing most to the misclassification, bear_nuke in this case, is identified, and the impact of increasing the threshold value on swapping the prediction is shown. A UMAP projection of all training samples is also presented, with colors representing class and brightness indicating the local relationship of these samples with the sixth decision stump. Each input dimension encodes one decision stump of the investigated surrogate model, with values of 0 for samples in the left subtree and 1 otherwise. This allows for the study of how threshold value changes affect specific samples both locally and globally. The design of the UMAP projection is carefully considered, with color used instead of shape to visualize sample classification due to its greater effectiveness. To mitigate overplotting, the number of instances is restricted, and techniques such as zooming, panning, and edge bundling are employed. Test set results are also presented, showcasing the ground truth and predicted results for every test sample, along with the difference in weighted probability required to switch the prediction from one class to the other. This enables users to evaluate whether changes to the surrogate model result in overfitting. DeforestVis is a visual analytics tool designed to analyze the behavior of machine learning models using surrogate decision stumps. It provides an interactive visualization that allows users to understand how each feature contributes to the prediction outcome, as shown in Figure 6. This figure illustrates the analysis of decision stumps, explaining how slight insulin amounts classify patients as diabetic. By hovering over a feature, users can trace the path of how the aggregated rule was created. The model appears confused, with a balance between 6 present decision stumps, 3 suggesting the positive class and the rest suggesting the opposite. The largest weight rule is divided, eliminating itself from the prediction outcome, and the remaining rules make the decision. The bar charts to the right of delta, W times P, display the contributions of each feature proportional to all features for the prediction of each test sample. Color encodes the predicted class, and color saturation double encodes the influence level per class to highlight the most impactful features for a given test instance. The design discussion highlights the use of simple yet effective visualizations, such as bar charts, histograms, and projections, to minimize the learning curve for new users. To address scalability issues, the authors suggest grouping similar samples and visualizing only the misclassified test instances. The current granularity level of DeforestVis offers many benefits, including being able to explain specific test instances and trace back raw data instances to the surrogate model's internal parts. The presented use case demonstrates how DeforestVis evaluates the behavior and summarizes the knowledge generated from a complex ML model. The tool allows users to vary the complexity level of the surrogate model in different ways to explain an entire complex model with only a few trees, resulting in an adaptive design that may be more practical to real-world scenarios. The authors explore the dynamics of different surrogate models, observing that rounding the thresholds of the decision stumps to 2 decimals leads to the highest possible fidelity in all 50 surrogate models. They then choose to explore a simplified surrogate model composed of only 3 decision stumps, which reduces complexity drastically while maintaining high fidelity. In the realm of machine learning model analysis, DeforestVis emerges as a powerful tool for behavioral analysis through surrogate decision stumps. A prime example is Amy, a data analyst at a hospital, who leverages DeforestVis to enhance her diabetes dataset predictive model's performance. DeforestVis aids Amy in identifying and adjusting problematic decision stumps, notably the one related to the insulin feature. This process significantly improves the surrogate model's fidelity, allowing her to present her findings to experienced doctors. They can then verify the hypothesis that the updated surrogate model performs as expected or better than before, potentially incorporating their knowledge into it. The use of DeforestVis in this scenario demonstrates its capacity to facilitate collaboration between data analysts and domain experts, ultimately leading to more accurate and reliable predictive models. This tool not only simplifies the complex task of behavioral analysis but also provides an interactive visual interface for users to understand and refine their models efficiently. By utilizing DeforestVis, Amy can delve deeper into the intricacies of her diabetes dataset, uncovering insights that might have been overlooked without the aid of this innovative tool. As she navigates through the decision stumps, she gains a clearer understanding of how each feature contributes to the overall prediction, enabling her to make targeted adjustments that enhance the model's performance. Moreover, DeforestVis allows Amy to explore different scenarios and test hypotheses in a controlled environment, reducing the risk of overfitting or underfitting her model. This capability is particularly crucial in healthcare applications where predictive accuracy can significantly impact patient outcomes. In conclusion, DeforestVis offers a unique solution for behavioral analysis of machine learning models, providing users like Amy with the tools necessary to refine their models and collaborate effectively with domain experts. By streamlining the process of model improvement, DeforestVis has the potential to revolutionize the way we approach predictive modeling in various fields, including healthcare. DeforestVis, a visual analytics tool, has been evaluated for its efficacy in facilitating understanding of machine learning models through surrogate decision stumps. 5 experts, including assistant professors, senior researchers, data analysts, and PhD candidates, participated in interviews to provide feedback on the tool. Their feedback was largely positive, highlighting DeforestVis's potential for surrogate modeling and its ability to provide transparency in decision-making processes. The experts praised the tool's flexible workflow, which allows for top-down, in-between, and bottom-up approaches to understanding complex models. However, they noted a steep learning curve and suggested incorporating indicators to guide users on where to focus initially. To enhance collaboration between model developers and domain experts, the experts recommended focusing on feature-based modifications rather than decision stumps. They commended the visualization and coordination aspects of DeforestVis, particularly the interaction between performance and uniqueness in the dot plot with lines, which helps identify less influential and duplicated decision stumps. The tool's suitability for both real-world applications and educational purposes was appreciated, offering a clear explanation of how AdaBoost works. However, suggestions for improvement included comparing model-based extracted distributions against actual data distributions to ensure the model behaves as expected, thereby increasing user trust in the selected surrogate model. Overall, The evaluation demonstrates the effectiveness of DeforestVis in providing insights into complex machine learning models and facilitating collaboration among stakeholders. The evaluation of DeforestVis, a visual analytics tool designed to analyze the behavior of machine learning models through surrogate decision stumps, reveals several areas for improvement. Experts have identified issues with scalability, particularly concerning the number of features and instances that can be handled by the tool. They suggest aggregating similar training samples and using progressive visual exploration to overcome these limitations. Additionally, they propose enhancing interactivity by implementing lasso selection in the UMap view to find samples classified similarly in the same subtrees by decision stumps. Experts also pointed out the need for more intuitive color mapping in Figure 1.2, with a reversed gradient from yellow to blue to better reflect the perceived strength of features. Furthermore, they emphasize the importance of maintaining an external dataset to avoid bias when tuning the surrogate model to fit well a test set. The tool's focus on binary classification is seen as a limitation, but experts acknowledge that the proposed visual designs could be applied to multi-class classification problems, focusing on segmented bar charts that summarize predictive power and thresholds for each feature. Overall, DeforestVis aims to assist model developers in understanding their model's behavior to further optimize them and help domain experts use simplified and tunable surrogate models for prediction instead of complex ML models. By visually examining surrogate models, developers can gain insights into how these surrogates represent the original model, which can lead to better model optimization. DeforestVis is a visual analytics tool designed to aid in the analysis of complex, black-box machine learning models. It utilizes decision stumps from the AdaBoost algorithm to create surrogate models that approximate the behavior of a target model, providing users with an interpretable alternative. DeforestVis features linked views that enable users to balance complexity and fidelity, minimize precision, and explore decision stumps in various ways, including purity, impactfulness, and predictive outcomes. Users can override rules, compare them on local and global scales, and focus on specific test cases to understand their classifications. The tool has potential for extension, such as incorporating more complex fidelity measures, improving accessibility for novice users, and backpropagating changes to the target model. Further research is needed into incorporating a feedback loop that refines the target model based on surrogate threshold adjustments. This research paper presents the development of a visual analytics tool, DeforestVis, designed to provide insights into the behavior of machine learning models by leveraging surrogate decision stumps. The authors conducted expert interviews with 5 data analysts and model developers to understand their needs and preferences in interpreting complex models. They found that current tools often lack intuitive visualizations and interactive capabilities, leading to difficulties in understanding model behavior. To address these challenges, DeforestVis was developed as an interactive visualization tool that allows users to explore the structure and behavior of decision forests through surrogate decision stumps. These stumps are simplified models that approximate the behavior of complex models, making them easier to understand and interpret. The tool utilizes several key features, including node link diagrams for visualizing tree structures, scatter plots for analyzing feature importance, and parallel coordinates plots for comparing multiple models. These visualizations are interactive, enabling users to select specific nodes or features to gain deeper insights into the model's decision-making process. In addition to its visualization capabilities, DeforestVis also includes a range of analysis tools, such as feature importance scores and partial dependence plots. These tools help users understand how different features contribute to the model's predictions and how changes in these features affect the output. The authors evaluated DeforestVis with a case study involving a real-world dataset and received positive feedback from the participating experts. They noted improvements in their ability to understand and interpret the behavior of their machine learning models, as well as increased confidence in making decisions based on these models. While DeforestVis has shown promising results, there are several limitations and areas for future work. For instance, the tool currently supports only decision forests and may need to be extended to accommodate other types of machine learning models. Additionally, further research is needed to fully understand the cognitive benefits of using surrogate decision stumps for model interpretation. Overall, DeforestVis offers a novel approach to visualizing and interpreting complex machine learning models, providing users with intuitive and interactive tools to explore the behavior of decision forests. By leveraging surrogate decision stumps, this tool has the potential to significantly improve our understanding of machine learning models and enhance decision-making processes in various domains. DeforestVis is a novel visualization technique designed to facilitate the understanding of complex machine learning models, specifically focusing on surrogate decision stumps. By visualizing the internal structure and decision-making processes of these models, DeforestVis aims to provide insights into their behavior. This approach combines dimensionality reduction techniques, such as UMAP, with interactive visualization tools, like Plotly, to generate an interpretable representation of the model's decision boundaries and feature importance. The technique operates in three main stages: extracting decision stump data from the machine learning model, applying dimensionality reduction techniques to create a 2D or 3D representation of the stump data, and generating interactive visualizations using Plotly. These visualizations include scatter plots, bar charts, and parallel coordinates plots, which enable users to explore the model's behavior in detail, analyzing relationships between features, feature importance, and decision boundaries formed by the model. Through several case studies involving real-world datasets and various machine learning models, including random forests and gradient boosting machines, the authors demonstrate the effectiveness of DeforestVis. By providing a unified framework for understanding and interpreting complex models, DeforestVis contributes to the growing field of explainable AI and machine learning, enabling researchers and practitioners to gain deeper insights into their model's behavior and make more informed decisions. DeforestVis is a visual analytics system designed to analyze and interpret machine learning models, with a focus on surrogate decision stumps. By breaking down complex models into simpler components, DeforestVis provides users with an interactive and intuitive way to understand model behavior. The system operates on the principle that decision trees, fundamental components in many machine learning algorithms, can be simplified and visualized as surrogate decision stumps. These stumps retain essential information about the decision-making process while omitting less relevant details. Model interpretability is crucial in machine learning, as users often struggle to trust and understand predictions made by complex models. Previous work on visualizing decision trees has primarily focused on static representations, which may not be effective for large models. DeforestVis addresses this issue by providing an interactive visualization tool that allows users to explore and understand surrogate decision stumps. The system utilizes a hierarchical layout to display stump structures, enabling users to drill down into specific parts of the model to gain more detailed insights. Additionally, DeforestVis supports various interaction techniques, such as filtering, sorting, and highlighting, to facilitate exploration and understanding of the model's behavior. A case study demonstrates the effectiveness of DeforestVis in analyzing a real-world dataset. The system is used to identify and visualize the most influential features in a gradient boosting machine model trained on a diabetes prediction task. The results show that DeforestVis can effectively reveal the relationships between input features and the model's predictions, providing valuable insights for both researchers and practitioners. By leveraging hierarchical layouts and various interaction techniques, DeforestVis bridges the gap between model complexity and user comprehension, ultimately enhancing trust and understanding in predictive models.